Okay, so the resistance means it's block the current flow. This resistance is experienced equipments are called as resistor. Okay, the resistor is denoted by just like that zigzag way. The representation of resistor is just that zigzag way. Okay, the normalic line we should denote it by the normal conductor, and the zigzag representation is denoted by resistor. Okay, the resistor is commonly two types: fixed resistor and variable resistor. Fixed and variable resistors. Fixed resistor and variable resistor. Okay. The fixed resistor is denoted by in this way, in the zigzag way, and the variable resistor, one of the example of the variable resistor is rheostat. So what is the difference in between them? Fixed resistor means, I am just taking one of the example like that. A resistor, it have a value is 5 ohm. The meaning is that always the resistance value is 5 ohm. We cannot to change that value. But in the case of rheostat, we should consider like that 0 to 10 ohm. The meaning is that we can choose the value of the resistor 0, 1, 2, etc. up to 10 ohm. The meaning is that fixed resistance value is always constant, and the variable resistance value we want to choose it depends on the particular circuit explanations. Clear? Okay. So in this diagram we should consider here, first one is the cell combination and key, rheostat, a fixed resistor, B for the voltmeter, and the A denoted by ammeter. You already studied in the 8th standard what is ammeter. Ammeter is an instrument help to measure the current flow. Okay. And next one, voltmeter. Voltmeter is the another equipment is help to measure potential difference. One more the common equipment we have to use in the circuit diagrams, that is galvanometer. Galvanometer and ammeter. What is the difference in between them? The galvanometer is denoted by the symbol is G. Galvanometer. Okay, galvanometer. It helps to measure the presence of the current. It helps to detect the current, but it do not measure the current. But in the case of ammeter, it is measure the current. That's the difference in between them. Galvanometer help to detect the current, ammeter measure the current, and voltmeter is measure the potential difference also. I hope you can understand these three fundamental electrical equipments we are used in the electric circuit: voltmeter, ammeter, and galvanometer. Voltmeter help to measure the potential difference, ammeter help to measure the value of current, and galvanometer help to detect the presence of current. Okay, so in our circuit diagram we are commonly to see, first one is cell. All the cells have the two ports. One is positive and another one is negative. The largest line is denoted by, that is the positive sign, and the smallest one, that is denoted by the negative sign. So this is the combination of the cells. How many cells in this circuit diagram? Two cells in the circuit diagram, as you are right. Positive, negative, then negative combination. Okay, this positive is connected to a ammeter. So you can see here the positive of the cell connected to positive of the ammeter side, and the negative of the ammeter is connected to positive of the voltmeter. So the voltmeter is here, and another one, the ammeter is connected seriously in the circuit. Series connection is there in the case of ammeter. But in the case of voltmeter, the voltmeter is connected across the load, across the resistor. That means the connection is just like a parallel way. So ammeter is always connected in the circuit in a series form, and the voltmeter is always connected in the circuit just like a parallel way. Okay. Then the next one, connected to the rheostat also. Whenever we switch on the key, how to switch on the key? Maybe in the graphical representation, the dot is not here. The meaning is that the key is switch on. Theoretically, we know practically how to switch on the key or how to work in the electrical circuit. It's another one. So theoretically, how we have to explain? When the dot is inside it, the key is closed. The dot is not here. The meaning is that the key is open. Whenever the key is open, the electron start to flow. That means current flow is there. So I just opened the key. What is the direction of current? The first video we already studied. What is the direction of current? Yes. Please tell the answer. What is the direction of current? Yes, you are right. Direction of current is opposite to the direction of electron. So what is the direction of electron? Yes, direction of electron means negative to positive. That means the current flow direction, that is positive to negative. Okay, come back. So current flow is starting from positive of the cell, passing through the way and enter to the negative side of the cell. Am I right? Yes. So current is starting from here, positive, passing through the ammeter, passing through the voltmeter and the load, and entering to the rheostat and come back to the negative side of the cell. This is the way of the current flow. Okay, positive to negative. So whenever the current is starting from the positive side, entering to the ammeter. So what is the function of ammeter? Ammeter to measure the current. Am I right? So I am just writing here the ammeter reading in the table. Okay, I am just consider this table. This table is contained as series number, voltmeter reading, ammeter reading, and resistance value. Okay. So I am just taking the ammeter reading because the current is passing through the ammeter to show the deflections. From that deflection, I can to take the measurement of current. Clear? Okay. So I am just getting the answer of ammeter reading 0.3. After that, the same current is entering to this point. And whenever the current is entering to this point, the current have two directions. One is passing through the load, other one is passing through the voltmeter. Clear everyone? Whenever the current is passing through the load, this much of potential difference we have to measure from this voltmeter. I repeat once more, the current is starting from the positive side, entering to the ammeter. Ammeter is helped to read the current value. After that, the current is entering to this point. Whenever the current is touched to that point, the current having two different paths. One is passing through the load, other one is passing through the voltmeter. Clear? Okay. Then the current is passing through the load. In between this point, I am just calling that points are A and B. Okay? A and B. In between the A and B, some of the potential difference is present here. I am right? Everywhere the potential difference, then the current will be start to flow. So that's the reason that already potential difference is here and the current is start to passing through the load. The potential difference is measured by using this voltmeter. So I am getting the difference value from the voltmeter here. I am just take that measurement and write it 0.3 in the meter reading. Maybe I am getting the answer 0.6 in the voltmeter reading also. Then the current will be entering back to the rheostat. What is the function of the resistor? Rheostat is one type of a resistor, I am right? So function of the resistor means it to block the current flow. Maybe 5 ohm or 10 ohm or 6 ohm, any how much of value we should provide, that much of current will be blocked in the case of the function of the resistor. So the rheostat is also do the same thing. It will be block the current and how much of resistance value is there, that much of current will be blocked. The balance current will be passing through the cell and entering to the negative side. So this is the function in the case of this circuit diagram. So don't bother about what are the main things or going on this explanation. So we just bother about, we should get the readings of ammeter reading, that means current value, voltmeter reading, that means potential difference. From this circuit diagram we want only that two readings. First one is ammeter reading and voltmeter reading. So change the value of resistance. Put 2 ohm, then 2.1 ohm and 1.9 ohm. I am putting into different resistance values and taking the ammeter and voltmeter reading and make this diagram, make this table. Okay. Depends on this table, I start to draw the graph based on the Ohm's law. I have already explained what is the Ohm's law equation. What is the Ohm's law equation? Voltage is directly proportional to current. I am right? Yes. Voltage is directly proportional to current. So I am consider from this graph, Ohm's law graphical representation, always voltage in x-axis. Okay, always voltage in x-axis. Voltage. What is the unit of potential difference? Otherwise, voltage. Yes, volt is the unit. And current I in the x-axis. What is the unit of SI unit of current? Ampere. Okay. You can just see here 0 0.3, 0 0.6, 0 0.5, 1, 0 0.7, 1.5, 0 0.9, 1.7. What is the meaning? Whenever the current increases, potential difference also increases. Otherwise, voltage increases, current increases. So you should get the answer like that, gradually increasing the both values, voltage and current. Okay. Then from this graph, how to identify the value of R? The meaning is same. V increases, I increases. V decreases, I decreases. That's the reason we have to tell it as V proportional to I. Okay. Then convert into this constant term, equalized term, V equal to IR. What is the value of R from this graph? How to find out the value of R from this graph? So we want to find out the value of R in this graph, we should find out the slope of the graph. Okay, we want to find out slope of the graph. In the mathematically trigonometrical way, we want to find out the slope of the graph to find out the value of tan theta. But in this case, we cannot be using that method. We have to find out the slope like that. X and Y components, A, B and C. So I'll just find out the slope of the graph. This one is delta I and this one is delta B. Am I right? This is the B, change in voltage and change in current. So we should write it as the value of R, otherwise the ratio delta I by delta B. That means AB by BC. This is the slope of the graph, otherwise the value of R. From this explanation, from this equation, we want to write it as B equal to IR. So R equal to B by I, am right? And I equal to B by R. So the same way, R equal to B by I. The same way, R equal to delta I by delta B from this graph. So I tried to explain the experimental verification of Ohm's law from this video. So what is Ohm's law? V proportional to I. Who has discovered that? Graham's Ohms has discovered the Ohm's law. What is the condition of Ohm's law? The same physical conditions are exist. Voltage is directly proportional to current. Am I right? Yes. So how to change the proportionality? Adding a constant. That constant is called as R. R means resistance. So V equal to IR. Graphically, we want to represent this just like a linear way. Always voltage in x-axis and current in y-axis. Linear in direction. From this graph, how to find out R? Trigonometrically, we want to take the value of R in tan theta. From this graph, we have to consider slope. How to find out slope? Taking the expression delta I by delta B. I am taking the names like that A, B and BC. So that is equal to R. R equal to delta I by delta B. This R is called as resistance. And what is resistor? The resistance is happening in some electrical equipment, that is called as resistor. What is the symbol of this resistor? Ohm is the symbol. Ohm is the symbol of resistor. Okay.